We're going to start with example 3.6. This example is also shifted gradient. The only difference between this example and previous one is the other one was increasing gradient. This is going to be decreasing gradient. So the same problem. You want to know how much you're going to deposit? I forgot. So it's going to be example 3.6. You want to know how much you should deposit at time 0. So you can withdraw like this. There's no withdrawal at the end of year 1 or 2 or 3 here. The first withdrawal is going to be year 4, and it's going to be 3,000. Now the size of the withdrawal is going to decrease by 500. So this is year 4, 5, 6, 7, 8. For example, year 5 is going to be 2,500. It's going to reduce by to 2,000. Year 7 is going to be equal to 1,500. And the last one is year 8, 1,000. So you can see the difference between this example. Your gradient is decreasing rather than increasing, and also is shifted. So how are we going to do this example? So the way we're going to do it here is we're going to add some artificial payment here. For example, here I'm going to add 500. I'm going to add here 1,000. I'm going to add 1,500 here. So this is 500. We call this one artificial payments. This is 1,000. Because these are not the actual payment, I'm going to add to it. Then I'm going to subtract. So this is going to be 1,500. And the last one is going to be 2,000. Now I have a uniform payment because 3,000, 3,000, 3,000, 3,000. So I can find the present worth of those payments. So I have a uniform payment of 3,000. You're going to multiply this one by P given A because the present worth of a uniform payment. And the interest rate for this example is 16% per year. So 16%, and the number of period is 1, 2, 3, 4, 5. 5 payments. Now remember, that's going to be the present worth at time 3 here. You want to know how much is worth at time 0. You're going to multiply by P given F factor. P given F, 16% and 3 period. So once you do this, that's going to be the present worth of 3,000. Remember, we add 500 here. These are not the actual withdrawal. We added the artificial payment, 1,000, 15, and 2,000. Now we have to take it back. So if you remember, this is shifted gradient. 500, that's if you compare this one with the gradient we have before, this is P. There's no increment here. This is year 2, year 3, and this is year N. So this is G, this is 2G, and continue up to year N is N minus G. That's a conventional gradient. This is a shifted gradient. So we got $500. That's the gradient. Remember, we call this on year 2 because the increment is at the end of year 2. We're going to call this on year 1, and we start the time here. This is year 0, 1, 2, 3, 4, 5. Now this is very similar to this gradient. So 500 multiplied by P given G, and the interest rate is 16% and 5 period. By the way, should not positive, negative, you're subtracting because we add those payments, now we have to take it, deduct from the equation. So it's going to be minus 500, P given G, 16% and 5 years. Now remember, that's not going to be at time 0, it's going to be at the end of year 3 here. So you have to bring it back. So you're going to multiply this one by P given F, 16%, and 3 period, because this is the present worth of the gradient at times 3 here. You will take it back to times 0. So this is the present worth of those payments. Now we're going to substitute for the factors. Now, the P given F from the table is going to be 3.2743 here. The P given F is going to be 0.6407. And the P given G is going to be 5.5937. And again, the P given F, the same factors, 0.6407. If you multiply and simplify this equation, the P value is going to be equal to $4,501.60. That's going to be the present worth of those. It means if you deposit this amount of money at time 0, you're going to be able to withdraw 3,000 here, 25 out of year 6, 5, and 2,000 year 6, 15 year 7, and 1,000 at the end of year 8.